When we go to IUPAC naming, I break it up into pieces because every piece tells us something. Same way, for aldehydes, IUPAC system, if you're following the IUPAC naming, the name is broken down into alk and al. Those are the three parts. What does alk tell us? What does alk tell us?
Parent?
What does alk tell us in any family for that matter?
Carbon.
In the parent
Oh,
chain.
parent chain, okay.
It's the number of carbons in the parent chain. That's the only job this thing has. No matter what family you are looking at. This always tells us how many carbons in the parent chain.
Parent chain.
Now the parent chain goes by order of priority. And I think I wrote down the order of priority once, but we can write it down again later. I think I have a handout on Canvas with the order of priorities listed as well. So far, all the families we've seen so far, the parent will be the one that contains the aldehyde. Everything else that we've learned so far are lower in priority than aldehyde. Aldehyde will be the priority compared to all the families we've seen so far. Alcohols or alkenes, alkynes, benzenes, whatever we've seen so far, they are all lower priority compared to aldehydes so far. Okay, so that becomes highest priority. Even if that means you're choosing the smaller chain, it should contain the aldehyde group. Everybody okay? So if that's the highest priority group, which carbon gets the, and then you number the carbons in the parent, right?
Mm-hmm.
Where do we start numbering from?
Lowest number.
Yes. Where do you put the lowest number?
C aldehyde group.
Exactly. Absolutely. It's the aldehyde carbon that is carbon number 1. That's where you start from. Because it's the highest priority so far. Okay, what does this tell us? AN?
Alcan.
Meaning what?
And
Guys, you've done this before. We've done it more than a couple of times already. What does AN tell us?
and is, come on.
We're counting on you, Carter.
Oh guys, come on, no,
I'm
we've
just
done
kidding.
this. We've done this many times.
Oh, sp3 hybridized.
What?
Hybridized carbons.
Where? In the parent. Basically, that is saying that all the carbon-carbon bonds are single bonds in the parent. What would you do if there were carbon-carbon double bond in the parent? What would this become? Ene. What would it become if there were a carbon-carbon triple bond?
Fine.
You change it accordingly. Have you seen this before?
Yes.
What does al tell us? Al at the end. Highest priority group or the parent group, why am I doing that? Is the aldehyde. Basically it's saying that's the parent. Aldehyde's the parent. Everybody okay? Now, think about this, guys. How many aldehydes can we have in one parent chain?
1.
Think about it. Pause. Think. How many aldehyde groups can I have in a single parent chain?
2.
Why 2?
You could go on each end.
Why can it only be on the end?
Oh.
Why can't I have it in the middle and be part of the parent?
Because of the hydrogen.
Because of the hydrogen. The maximum number of aldehyde groups there is possible to have in one parent is 2 on either ends, because that marks the end of the chain. If that's not the end of the chain, it can't be a aldehyde. Aldehydes can only be at the end of the chain. Does that make sense, everybody?
Mm-hmm.
So what if there were 2 aldehydes in one parent? Then how do you change this name? Anybody? And what else? You're right, of course. If there were 2 alkane and dial, of course, yes. What else changes? If there were 2 alcohol groups on a parent, or more than 1 alcohol groups on a parent, what else did we change?
Alka. Aim.
Exactly.
Aim.
Of course, the alka, the A part that you're talking about, is if there were more than 1 ene or more than 1 ine in the parent, then you have an A there to suggest that. Make sense, everybody?
Mhm.
What if there were an aldehyde group on a ring? Now think about this also. Try and picture it in your minds. Can an aldehyde group be part of a ring? Is it possible for an aldehyde group to be part of a ring, enclosed in a ring?
No.
Not possible. To be enclosed in the ring, you will have to have R's on both sides. But then that's not an aldehyde, that's a ketone.
Not true.
Isn't that right?
Yes.
So, but can an aldehyde group be hanging off a ring?
Yes.
Yes.
Absolutely. So in that case, how do we name those? Those are named as cycloalk, as you would expect. But here things change a little, quite a bit. Ane carb aldehyde. Because we have to account for that extra carbon that's hanging off the ring, which you can't count in the ring. You can't because it's not part of the ring. Those are called cycloalkane. Please note the E, carbaldehyde. Cyclopropane carbaldehyde, cyclohexane carbaldehyde, so on and so forth. There is one cycloalkane carbaldehyde that has its own special name. What is that special name?
Benzaldehyde.
That guy has its own special name. Everybody okay? So far with the rules for aldehydes? Let me make sure I didn't miss any. Okay. What about ketones? And then we'll do examples. Let's just write the rules first, then we'll look at examples. What about ketones? Ketones in IUPAC are not ketones. They are called, once again, please notice the similarities and differences. They are called alk and ones. They are alkanones. Again, what does alk tell us?
Parent chain.
Again, you got to
Number of carbons in the parent.
in the parent chain. What should be the parent? The parent should be the one that contains the ketone. It should contain the C double bond O, the carbonyl group. Exactly. And the parent, because the ketone is the highest priority, you should number the parent in such a way such that the carbonyl carbon gets the smallest number. Everybody okay? Same thing throughout. What does that tell us? Well, all the carbon-carbon bonds in the parent are single bonds.
Single.
If there were an alkene, this becomes an ene. If there were an alkyne, this becomes an ine. Make sense, everybody? And then one. Ketone is the line. We good? Now, there's a big difference between alkanal and alkanone. Think about this, picture in your mind. What will always be the position of an al?
At the end carbon.
Okay, what number would that be?
1.
So, if there's only one aldehyde, it will always be 1 at position 1. So we don't have to give it. We don't have to say it because it will always be 1. But if it is a dial, we must give position. even though it's kind of implied, but we should